All right, I want to do a little recording here for lesson 4.8. I'm just going to do a few problems from page 336, you guys. And I will assign different ones. So the first one I'll do is number 11. Now you see that for exercises 5 through 14, your picture looks like this. And they have this to be C, so this is big B and this is big A, so then this has got to be little a, little c, and little b. So you're going to use that picture. I think I assigned 10 and 14, but here's number 11. It gives you that b is equal to 16 and c is equal to 52. So if I put that on there now, the 16 is going to go here, and the 52 is going to go here. Now it's not drawn to scale, but you have the whole thing. Now the problem says to solve the triangle. So that means find all the missing parts. So if I start with this angle right here, angle A, from this angle, the 16 is adjacent and the 52 is hypotenuse. I'm going to write cosine angle A equals 16 over 52. Now, when you're trying to find the angle, you work backwards. So on the calculator, you type this in, inverse cosine 16 over 52, and you make sure you're in degree mode, and then you end up getting angle A to be 72.08 degrees. Okay? So then angle B is going to be 90 minus angle A. So then angle B is going to be 17.92 degrees. So now you know angle A, angle B. The only thing that's left is to find little a. Well, can't we use Pythagorean theorem? So a squared is going to be c squared minus b squared. So a squared is going to equal 52 squared, subtract 16 squared. And so a squared is going to end up being, well, let's just go right to the chase, and you do this on your calculator, take the square root, and you get a to be 49.48. So you found angle A, angle B, and little a. Angle C is obviously 90, so you've solved the entire triangle. All right, the next one I'm going to do is problem 17. Now notice in your book, this is your picture for problems 15 through 18. Theta, theta, and b. So isn't this an isosceles triangle? Because the base angles and the legs are congruent. So you have an isosceles triangle. In question number 17, they tell you that b is 8 and theta is 32 degrees. So I replace this with 32, this with 32, and this with 8. Now, I need to somehow make a right triangle out of this. So I'm going to take this picture and I'm going to draw the altitude to the hypotenuse, because the problem wants you to solve for the altitude. Well, the altitude is this right here. It's the height of the triangle. I'll call it letter A for altitude. This is 32. Now, these two triangles would be congruent, so if this whole side is 8, each of these is 4. So now your picture looks like this. This is 32 degrees, this is A, and this is 4. So from the 32 degree angle, A is opposite, and this is adjacent. So we write tangent 32 degrees equals A over 4. And to solve for A, we're going to take 4 times the tangent of 32 degrees, and we end up getting little a to be 2.50. And that's your answer for number 17. So again, about splitting that triangle into two congruent triangles, you draw in the altitude, and that makes these two triangles, both right triangles are congruent, so you can split the 8 into 2, 4, and 4, and then you got the angle. Okay, the next problem I'll do is question 21. Now you can look on this, and it talks about a ladder. So the ladder is actually leaning on a wall. So this is my ladder right here. I'm just trying to make that look like a ladder. And it tells you the angle of elevation for number 21 is 80 degrees. So here's my right angle. It leans against the side of a house. So over here is my house. And it says the angle is find the height from the top of the ladder to the ground. So they want you to find this distance right here, which I'll call X. The ladder is 20 feet long, so I put 20 feet for the length of the ladder. So from this 80-degree angle, this is opposite, this is hypotenuse, so that's the sine ratio. So I write sine 80 degrees equals X over 20 feet. So X is going to be 20 times the sine of 80 degrees. Again, make sure you're in degree mode, and you get X end up being 19.7 feet. And that should be this distance right here. Now if they needed to find this distance down here, you'd have to use inverse cosine. Or excuse me, you'd use cosine. Okay, then let's do one more problem. And here's number 25. Now the picture for this is in your book. So you got an airplane up here, and we're going this way, and it kind of looks like this. Passenger in airplane at an altitude of 10 kilometers. So here's 10 kilometers for your altitude. Sees two towns directly to the east of the plane. Okay? So east of the plane. So if you look at the picture, they got this one town right here. Oops, not very good. And then the other town is this one right here. So it tells you that the angle of depression, so this angle of depression, now we need to put this dotted line in here that's parallel to this bottom side. So this angle right here is 28 degrees. Now, do you see the alternate interior? So this would also be 28. And this angle right here is 55. So if I look at that, this angle is also 55. So I'm going to put letter Y in for this right here. And this distance right here, which is what I want to find at the end, I'll call that Z. And then this distance right here, I'll call X. Okay, so don't we have two right triangles, the little one over here and the big one here? So if I write tangent 28 degrees equals opposite 10 over adjacent X, I'll find this whole side right here. Now if I take 10 divided by the tangent of 28 degrees, I get X equal to 18.81 kilometers. All right, now I can solve for Y, and if I get X and Y, I'll take X, subtract Y, and get Z. So in this triangle right here now, the tangent of 55 degrees equals 10 over Y. Again, 10 divided by the tangent of 55 equals Y. So Y is going to equal 7, pretty much right on the nose. So then the problem said, how far are the towns apart? That's Z. So Z is going to equal the X, which is 18.81, subtract Y, which is 7. And so my final answer is 11.8 kilometers approximately. So hopefully those problems there will help you, and it's not a very long video, but I'll probably do one more problem together in class, not on the video, on bearings, and we should be good. So check this out, and hopefully this will help.